I will take this opportunity to give you a description on the fundamentals CFD software developed. There are two major codes we're developing. One is called Code 1, the other one called Code Leo. All right. So what you're gonna see is next chart is to show you what is 1, what is Leo. Right? 1 is a mesh generation code specifically written for turbo machinery, and it provides various type of mesh to meet application needs. All right, and also can provide different type of granularity to the mesh, down to the very coarse mesh for invisible flow problem, to a highly dense mesh with very advanced mesh topology to cover the flow field. But remember, Code 1 is only a mesh generator for turbo machinery cascade problem. On the other hand, what we have is what we call Code Leo. That is a general purpose CFD flow solvers. And what do I mean by general purpose? Right. General purpose is that it can do both structured grid and unstructured mesh. And as long as we have the mesh, and it can provide solution. And of course, there's a limitation. The limitation is currently the assumption the flow is not chemical reacting zone combustion model in there. It is assumed ideal gas, right? But it can cover the Code 1. A Leo can cover the flow speed from low speed, for instance, 20 feet per second, 10 feet per second of air, to all the way to supersonic flow of 3.0 Mach number. Once you go beyond 3.0, now we are talking about, there's a dissociation of the real gas effect. So that's why the code is not applied to much higher Mach number, more than 3.5. And second, the code itself can do both steady state simulation or time captured simulation, what we call time accurate flow simulation. As the flow evolves with the time, it will capture what's going on as a function of time. That's called both steady state and time accurate flow solution. And since I mentioned to you the code actually, it can do both structured and unstructured mesh, and make this code very versatile for many, many applications. And we also captured the best quality of those mesh. For structural mesh, we are using the convention known things called multi-grid scheme to accelerate convergence. For unstructured mesh, we also have something called residual propagation scheme to help us to make the solution converge faster to a steady state you're looking for. In the Code Leo, we also have something called a conduction module we recently developed. The purpose of doing that is to do conjugated transfer for the long term to mitigate one of the major problems associated with turbo machinery is turbine durability issue. Turbine immersed in a very high temperature gas, and you have to cool it, and you need a capability to accurately, reliably predict the metal temperature to make sure we can design it, the turbine will not melt in this operating environment. And the last, one of the most important items is the code itself right now can run on a cluster of computers using very standard message passage interface, MPI routines. The code was developed, I developed the code since 2004, about 1 year after I retired from Pratt & Whitney. The reason I started rewriting the code is I did not find anything I'm looking for and in a commercial market, and I think I can do better, so I started development. Now it's about 5 years, and we have commercialized both Code 1 and Code Leo. This is a quick introduction